In this video, we'll look at some examples of calculations and visualizations of vectors in R3. Specifically, we'll look at how to calculate a unit vector, scaling a vector, and using mixed representations of the forms of vectors in doing problems. In this problem, we need to find the unit vector having the opposite direction of the vector w equaling 4i plus j minus 3k. If we try to graph these and look at them in three-dimensional space, well, here I have the x-axis, the y-axis, and then the z-axis here is this projection. So if I look at my vector w, you'll see that it's behind this gray area, which is the xy plane, and that makes sense because my vector w is 4 in the x direction, 1 in the y direction, and negative 3 in the z direction. And so I want to find the vector going in the opposite direction, and that's the negative of that value. So here you can see it's going in the opposite direction. And then what I'll want to do is I want to take that negative vector that I found and I'll want to scale it so that it's of length 1. And then I'll have found the vector that I'm looking for. In order to perform the calculations for this, well, I need to determine what the negative vector w is. Well, negative w is the opposite of each of these terms, so negative 4i minus j plus 3k. And if I want to turn it into a unit vector, well, if I have something of length 5 and I divide it by 5, well, then it becomes length 1. So I need to determine what's the length of negative w. And I could determine the length of w because they should be the same length, but I'll do it on negative w. And so the length of w will be, well, the x-coordinate negative 4 minus 0 because it's from the origin, plus negative 1 minus 0 plus 3 minus 0. So the length of w will be the square root of 16 plus 1 plus 9 to the square root of 26. And so then I'll take my negative w, I want to divide it by the square root of 26, and that'll give me the unit vector. So negative 4i divided by the square root of 26 minus 1j all over the square root of 26 plus 3k all over the square root of 26. So there I have my unit vector in the opposite direction of my original vector w. In this problem, we need to determine the vector of length 4 that has the same direction as the vector s equaling 3i minus 4k. If I look at this in three-dimensional space, I'll look at the vector s, and notice that the 3i, there's a 0 component that is the j, and 4k. So here we have the vector s, and what we want to do then is, well, if I want it to be of length 4, what I can do is first find the unit vector, so it'll be of length 1, so there I can find the unit vector there, and then scale that vector up by 4. So once I have that scaled, then you can see the original vector s, I look at the unit vector, and then the scaled vector here, which has length 4. So in order to perform those calculations, I need to first determine the length of the vector s. So the length of the vector s equals square root of 3 minus 0 squared plus 0 minus 0, the j component is still there, plus negative 4 minus 0 squared. So the length here is 9 plus 16 to the square root of 25, which equals 5. So the length of my vector s is 5. So what I want to do now is say, okay, well, if I take my vector s and I go ahead and I divide by the length 5, then I'll get my unit vector. So here now I could have 3/5 I minus 4/5 k. And I want that to be now of total length 4. So this is of length 1. So now if I take this whole thing and I multiply by 4, so now I'll say, well, let's say 4 times my s divided by its length of 5. That will get me my new vector, which will be 12/5 I minus 4 times 4 is 16/5 k. So here I have now a vector of length 4 that's going in the same direction as my original vector s. In this example, I need to determine the vector pq when p is 2, -3, 1, and the vector from the origin to q is given by 3i plus 2j minus 4k. If I look at this in three-dimensional space, well, I know that I have the point p as 2, -3, 1, and I have the vector from the origin to q given by 3, 2, -4. And what I want to find then is the vector pq from the point P to that point Q. So this is the vector that I'll be looking for. I have the point P given by 2, -3, 1. And I also know the point Q could be given by the point 3, 2, -4. So then the vector PQ will be the difference of 3 minus 2, that'll be the I component, plus 2 minus a -3, that'll be the J component, and then -4 minus 1, which will be the K component. So my vector PQ will be 1I plus 2 minus -3, 5J, minus 5k. So now here we have the vector pq defined by the point P and the vector q given by 3i plus 2j minus 4k.